Okay, we got geometry 4.5 isosceles and equilateral triangles. Objective is to use and apply properties of isosceles and equilateral triangles. Okay, we're going to classify triangles and by sides and by angles. We're also going to look at right triangles and isosceles triangles and their properties as well. So let's look at classifying triangles. Classification by sides. Equilateral triangles, all sides are the same measure. Okay? Isosceles triangles, two sides are the same measure. And scalene triangles, no sides are the same measure as we go through. Now, keep in mind as we're looking at this, if I'm talking about isosceles, if I'm talking about an equilateral triangle, if I can draw this with my little cursor, all these sides are the same. Okay? If I'm talking about an isosceles triangle, that has a base. Okay, this side and this side are the same. And then a scalene, if I do this, all the sides are different measures, so no sides are the same. Going on, we're talking about acute triangles, classification by angles. And if I'm talking about acute triangles, the largest angle is what is going to classify my triangle. So if my largest angle is less than 90 degrees, it's going to be acute. Equilateral triangles, all the angles are the same, so they measure 60 degrees. And we worked with equilateral triangles in chapter 3, and we're doing it again here in chapter 4. Right triangles, largest angle is a right angle, and that right angle is always opposite the hypotenuse. Okay, and a obtuse triangle. Again, largest angle is greater than 90 in an obtuse triangle. So there are three angles in a triangle. We classify whether it's acute, equilateral, well, equilaterals, all the angles are the same, but we're classifying the acute triangle, right triangle, and obtuse triangle by the size of the largest angle in that triangle. Excuse me. Now, right triangles. If you're looking at your online book, it's page 884, and I had originally done this as a self-study, but I'm having you guys do a self-study with a video today. Okay, we're drawing and labeling picture in space provided, so we have the space provided here, and when I'm looking at a right triangle, generally we have A and B and C, and the A and B are considered the legs. Now C, the hypotenuse, is always opposite the right angle. Now we have this, we've seen this a bunch of times before. This is the Pythagorean theorem, and it works only with right triangles. But keep in mind the legs, the shorter two sides, they are adjacent sides, they make the right angle, so these are the right angle. The hypotenuse is opposite the right angle, as we're looking at that. Okay, the hypotenuse is the longest side opposite the right angle as we go. Now, again, if you want to reread these, they're in your online textbook on page 250, 253. The isosceles triangle, as we look through it, and we got the isosceles triangle kind of side by side with the right triangle, they have legs too. The legs are congruent, and the congruent legs make the vertex. This is the vertex angle. Okay, so as I'm looking through, these legs that make that vertex angle are congruent. Okay, and in an isosceles triangle, there are two sides that are congruent, and those congruent sides make the vertex angle we talk about in an isosceles triangle. Now, the base, the third side, is opposite the vertex. So down here, I've got the base. It is opposite the vertex as I'm working through it. Okay. And you got to be able to orient ourselves with the picture that's looking at the triangle. And then we have base angles. Now, the base angles of an isosceles triangle are the same. Now, I'm going to let you in on a little secret. When I have three sides that are the same, I have three angles of the same because the sides are across from the angles that are the same. If I have two sides of the same, I will have two angles that are the same. If I have no sides are the same, I will have no angles the same in triangles. Okay, just kind of a little FYI. But this is an isosceles triangle, and this is us doing the anatomy of an isosceles triangle. Now, we have some theorems. Theorem 4.3, isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So we're talking if two sides are congruent in an isosceles triangle, they are, then we're talking the base angles are congruent. And this is isosceles triangle theorem. Okay. There is something called the converse of the isosceles triangle theorem. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. Okay, so these are converses of each other. So remember, if I have this and this here, I can switch their positions and I will have the converse. So I have an if statement, if-then statement. If in a triangle two sides are congruent, then the angles opposite those sides are congruent. If the angles, I have a triangle with two angles congruent, then the sides opposite those angles are congruent. So keep that in mind and how the isosceles triangle theorem and the converse of the isosceles triangle theorem work. Now, theorem 4.5. If a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. Okay? If the line of a bisects the vertex, okay, so this is a vertex, so ACB is bisected by segment CD, so that ACBD and BCD are congruent. Okay, and that's what we got. ACD is congruent to angle BCD, and AC and CB are the same. Then, if that is true, that line that does the bisecting of this vertex angle is perpendicular to the base, and it splits the base into two equal parts. Okay, so if a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. So not only is it perpendicular to the base, but it's bisecting the base where AD and BD are congruent. So keep that in mind. It's a nice little extra on a theorem as we're thinking about what's going on. So this is theorem 4.5. If a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. And this is what it looks like. Now, a corollary is a theorem that can be proved easily using another theorem. Corollary to theorem 4.3. If a triangle is equilateral, okay, if all three sides are the same, if a triangle is equilateral, then the triangle is equiangular. So if all the sides are the same, therefore all the angles are the same. So if I have three sides the same, I have three angles the same. If I have two sides the same, I will have two angles the same. And if I have no sides the same, there will be no angles the same. So keep that in mind as we're going through and thinking about triangles. Now there's a corollary to theorem 4.4. Remember, theorem 4.4 is this one, the converse of the isosceles triangle theorem. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. So let's talk about the corollary itself, the 4.4. And as we go through, bring those back up, the corollary is if a triangle is equiangular, then the triangle is equilateral. Okay, so if a triangle is equiangular, then the triangle is equilateral. So if I have three angles that are the same, then I will have three sides the same, the sides opposite each one of those angles. Okay, that's notes for today. I hope things are going well for you guys and that you have all your questions answered. If you don't, make sure you're talking to Bloom today. You'll have plenty of time for work time and be able to figure things out. Have yourselves a great day.